Hello, welcome to Data Science with EJD. In the past two videos, I talked about introduction to data science, and then in the following that, I talked about introduction to machine learning. So that means we'll be going on some machine learning journey. In this video, in particular, I'll be focusing on machine learning pipeline in Python. So, of course, you have an idea what a pipeline looks like, how the whole process flows when you talk about machine learning. Of course, we have been able to identify different aspects of machine learning like supervised learning, non-supervised learning, and reinforcement learning. So we're going to be taking different components of that as we go on. But in this particular video, we just want to look at an overview, a general kind of pipeline that machine learning activities follow as far as Python is concerned. Okay. Next, let's talk about machine learning pipeline and the key steps. So first of all, you have to load and explore your data set. Of course, we assume you already have your data set in place, right? If you go to data analysis with Python that I had done earlier, we looked at different ways by which you can obtain data. So let's assume all of that is in place. So you want to load and explore the data set to see what it looks like. Then you want to go ahead and pre-process the clean data. You want to do feature selection and engineering. Probably you need to do some binning. You need to do some coding. You need to maybe create new columns from existing columns and things like that. So you want to go ahead and do that. Now, a new concept that comes in when we talk about machine learning is the idea of train, test, split. So you have the whole of your data, right? So you are going to test a portion of train. You are going to train your model with a portion of the data, and then test what the model with another portion of the data. So we'll talk about that a little bit as we go on here. And then as we get to do specific machine learning tasks, you see how this actually plays out. Then from there, yeah, so we talk about the model selection and training. Of course, the training is with the data that you would have trained, the train and test split you would have talked about up there. Then you can do some prediction and evaluation with what you have. Then you can do hyperparameter tuning. Most times when you do the first, model selection and training, the results you get may not be what you really desire. So you may have to do some hyperparameter tuning to make the model perform better. Then, of course, you're also concerned about model persistence afterwards. Right. So, stepping away from that, let's look at some important libraries that you use when you talk about in working with in doing machine learning. Right. Of course, you see pandas for data analysis. So we still have some data analysis tasks going on here. You have NumPy also, which is for numerical Python, some numerical stuff, and then you also have Seaborn for visualization as well as matplotlib. I mean, we've seen this first for a whole lot. Now, the new things now, because we are talking about machine learning, is scikit-learn is the key like Python library for machine learning, right? So when you say sklearn, it actually refers to scikit-learn. So and from scikit-learn you have a module called model selection, and from that you can import the train test split, the grid search CV, and then from scikit-learn preprocessing, you can import standard scaler if you need to scale your data set. Then from scikit-learn, you have a module called linear model where you can import functions like a function like linear regression if you want to do linear regression. Then we also need to do metrics. So we need to get metrics for our how to measure the performance of our model. So we have a module called or yeah a module called metrics in scikit-learn, and from there you can import the some what can help you with mean squared error and R2 score. So these are some two metrics. There are many metrics for sure. Then you can also import joblib. Now joblib is what you use in if you want to deploy your machine learning model, as you're going to see as we move on. All right. So the next thing is you want to load and inspect data, right? Of course, you already have idea about how to inspect data from when we talked about data analysis. So for sure, since you have installed pandas as PD up there, right? You have installed pandas as PD. So your data now, you now want to read a CSV file. Uh, a data.csv. You have your data set is in data.csv. So since it is a CSV file, so you read the CSV file and you call that in data. Then you can now visualize. You want to see the info, which gives you the number of rows and columns and the data types and all. And of course, what amount of your disk it is taking. And you also want to have a statistical overview by using data.describe. Then you want to know the number of null values you have in your data set for each column. That's what that is null.sum does for you. Okay, so very important tips. You want to handle missing values and remove duplicates and explore value distributions. Now we considered all of this when we're talking about data analysis with Python previously. So the next thing we want to talk about is feature engineering, which I just made mention of not quite long. So here you want to encode categorical variables. So if you have categorical variables like maybe say gender, male and female. So instead of just having male and female, you want to call male 0 and call female 1. So that is a way of encoding. You can normalize numerical data also. We did something like that under data analysis with Python. You can also extract new features. That's the idea of feature engineering. Maybe a very good example would be distance and time. So you have maybe you have two variables called distance and time, and from distance and time you can actually get a new variable, a new feature called velocity by dividing distance by time, right? So here you can have data equals pd.getDummies, data draw first true. So this is you doing some feature engineering here. So and here you want to do some scaling, and then you're also extracting some features. So for feature one, feature two, maybe this feature of course will have specific names, right? And then you're using your scalar to transform them, and you have new data transformed like that. So that's the idea of feature engineering. And then you have split data sets. Now this is how you do split. So you have the X, which talks about what. So the X is every other thing. Of course, when you have a model, right, you have like y equals mx plus c. That's at least one of the simplest equations we can think about. So it means that y, which is the target, which depends on whatever x would be. So what is happening in this first line is that for all the other things that y depend on, so you drop the target. You want to drop the target variable, the target feature. All right. So once you drop it from there, so you have every other thing left, and then the y itself will now carry that target. So you're going to see that example in the next video where I'll do linear regression as I start with supervised learning, right? So and from there now in line 4 you have X train, X test. So your training data set, your test data set, then for Y to Y train, Y test, and then all of that is equal to train test split, which is a function that you have called previously. Then X comma Y test size 0.2. Now test size, it means you're testing with um 0.2, you're testing with 2% of the data you have. I mean, with 20% rather, and then you are training with 80%. That's what this means. And random state 42 guarantees that you don't get different results each time. It helps you to get the same results if you do that, even if you do the same thing several times. So the split ratios, typical values for split ratios are 70-30, meaning that 70 goes for training and 30 goes for test size. So if you use 70-30, it means that the test size will be 0.3. So, and once the system size is 0.3, automatically we know that the train size is 0.7. Then, but what we have used here is 80-20, meaning that you use 80 to train the model and you use 20 to test 80% of the data, right, of your data to test, to train the model, and use 20% to test how the model perform. All right. So that's the train test split. All right. So of course you can also have so maybe in some extreme cases or in some special cases you may have to think about maybe 67-33 or something like that. It all depends on your specific situation. And of course the data, the number of data points also matter in this case for sure. So all of that can come into consideration. So as we go on, we'll see some of these dynamics. Then of course, after doing all your train and test, imagine you want to do linear regression. So your model is linear regression, right? So model is a variable name. So you now want to fit the train, X train, Y train. So you fit that to a linear regression because the model here is actually linear regression. So this line to help is where you actually train the model on linear regression, and then we can go on. So behind the scenes, right, the mathematics that is actually happening when when you see this training is that you're solving least squares. You want to minimize the difference, all right, like that. So you have xw minus y. So you're minimizing w that makes this possible, right, as much as you can. So then you can also predict and evaluate. By the time you have done that, done what you did previously, right? That's the whole training the model thing. So you can now predict a value of the y to see how well it performs. So you have a predicted value. So you just a model that predicts x. So you now want to test use your test values for x now. Then from there, how to know how well your model performs, you now need to use all these metrics like mean squared error, so over the y test and y predicted. So you want to see between the y test and and the predicted y, what is the mean squared error? How well, what is y pred so departed from y test? You want to see that. Then there's also root mean square error, and that's where numpy comes in. So because you get sqrt, that so root mean square error is the square root of the mean square error, right? So and you need square root function from the numpy library, and then there's R2 score also, which is a very known test in statistics. So you have R2 score over the y test and y pred, and then you can now print all of that. So RMSE, you print R2, you print the RMSE formula. This is how it looks like: square root of 1 over n, square root, I mean summation from I equals 1 to n of y1. So you're basically looking at the departure between the test value and the predicted value for sure. So that's what that does there. And then most sometimes the performance of a model, maybe based on the metrics, you are not, maybe you get an R2 of say 0.5 or 0.6, and you want something higher, maybe something close to maybe some like 0.9 or 0.85. So you have to do some hyper parameter tuning. So here you're adjusting some values to see that can be. So this is a typical hyperparameter tuning setup. So from scikit-learn.ensemble, so now you're importing random forest regressor. So you look at the parameters. So the n estimators, you have 100 by 200 maximum depth. So I mean, you are digging deeper. That's what basically this is about. And for the grid, you do grid search CV, random forest regressor, which you've imported here, and then the parameters. These are the parameters you have put there, and then the grid fits now with the X train and Y train, and then you can now print grid best parameter. So with this now, you are tuning to see the best parameters you can actually get. So it's like you want to get your parameters between these two values and the depth. So you want to get n estimators and maximum depth between 0 and 10, and then number of estimators between 100 and 200 to see which one fits best. So at the end of the day, you're going to get the value for n estimators and maximum depth based on what this grid search CV is going to do on with the random forest regressor thing. So like that. So you can also change maybe CV5 to something else and all that to see what happens. So by the time all that is done and you have tuned your parameter and you have got something that you're comfortable with, then you want to think about how to save model for deployment. And a very popular way to do that is to use the job lib. You remember we imported job lib initial the other time when we are setting up. So you just have job-lib.dump, then the model, and you are now saving it as a trained underscore model.pkl. All right. So then you can then load it back later where you call the model and you say joblib.load this trained model pkl. This is how you can call it back. We're going to do something practical like this in the next video, the next two videos or so, right? So joblib.load train model.pkl. All right. So that's you trying to deploy. Okay, so data loading and preprocessing. So this is a summary of the whole machine learning pipeline. So you have data loading and preprocessing, which are foundational. Then you always want to evaluate with multiple metrics. So sometimes you don't know, should you use RMSE or you should use MSE or you should use R squared and all that. So you want to use many metrics and then make your decision across these metrics. Then hyperparameter tuning can boost performance. If you got something and you want something better, you can tune your parameters. Then you can also save train models for reuse. That's for deployment and all that. Okay, so feel free to in the comment section. Let me have your questions. And then of course you want to follow this series as much as you can. And of course, the other videos that can actually be like a build up. Like I have SQL with Python, I have data analysis with Python, I have a playlist on data, on statistics, probability, basic calculus, vectors, matrices, and all of these things build up here. So thank you for watching. Feel free to ask questions or comment on the video in the comment section. So if you want to go to my channel, you can subscribe to my channel. You just click on this and it takes you straight to the channel. All right, so you can see a whole lot of videos. So these are the first two videos on machine learning data, on data science, introduction to data science, and introduction to machine learning. So, and many other videos. So, if you click on playlist, you find all the possible playlists there, right? So you have all of these things going on right there. Okay. So apart from that, you may also want to, of course, so feel free to subscribe. And then you want to follow, if you want to explore this data science with EJD playlist, just click on this and then it takes you straight to the playlist. For now, we have two videos. Maybe by the time you're clicking, you have maybe five videos, or, the videos, they keep growing like that. Okay. So you can also you can also um, join. You can be a member of my channel because now I have membership. So if you click on this, it takes you to the membership page where you can be either a bronze, you can have bronze access, silver access, or gold access. All right. So all those are the possible things you can do on the channel as you follow along as much as possible. Okay. So watch out. In the next video, I'll be talking about linear regression. That'll be the first thing I take under supervised learning, and then along the line, after that, I'll be talking about how to deploy machine learning models. I'm sure you want to know that. Of course, we've seen the theory here, so you're going to see the practical in the next one or two videos like that. So let me know how helpful this video is for you in the comment section, and of course, be free to let me know if there's something you want me to try out. I might just be able to do that. Be sure to subscribe to the channel if you have not subscribed already. For those who have subscribed, thank you so much. So after subscribing, be sure to hit the notification bell so you can always get alerted each time a new video is released. And like and share also so that more people can have access to the great content I have going on here. So like, come your way again. Keep doing data right. Bye.